This video is going to demonstrate how to create this object in the drawings. The title of this object is the cam clamp slider base. There is a lot of detail here. We have some countersink holes. We have essentially some lofted little pyramids that act like a knurl, like some teeth to bite into objects. Those are going to be created with a pattern tool. We're going to use the hole tool on those countersinks. And firstly, we need to start off creating the general body shape. Now, before I take you step by step through, please try and create this on your own. That is a really important skill you need to develop, being able to create parts and objects from two-dimensional drawings. So please try it before you reference this video for the answer. All right, that's it. Let's go ahead and get started creating our drawing here. I'm going to create this general shape. I am not going to use a slot tool in here. I'm going to create this with arcs and lines because this does not have tangent relationships with most of the slots do, I believe. So let's go ahead and create this general shape. Okay, I think I'm going to put the origin just down at the bottom. A lot of different ways to do it. That's how I'm doing it today. I'm going to start off with, since everything here is symmetrical, I'm just going to make these equal to each other along with these lines as well. I'm going to get the general size by putting the largest one in there. And right off the bat, I can see I need some tangents here. Smooth these things out. All right, that's a good start there. One more thing would help would be vertical on that. That's going to hold everything together. All right, let's go ahead and try that slot now. So that slot's going to have two lines either side. I'm going to make those equal to each other. They're already vertical, so I don't have to worry about that. I'm going to put horizontal relationships at two of the points. Use some 3-point arcs. Now, when I'm making this arc, I want to make sure I do not allow it to put tangents in there. There'll be more work later to take them out. Okay, so kind of have the general shape and features. So let's start throwing some dimensions in there and see what happens. This is 0.82. The side here is 0.8. It's the length of that. This is 0.375, and if I look at the drawing, it's clearly symmetrical, so I'm going to use an equals to assign the size of both, although it didn't like that, so let's figure out what's going on. Oh, getting a little goofy on me. Let's take a step back and do the width of this slot. It's going to be 0.51. This slot is going to be in the middle, so I can use a vertical here, kind of hold that stuff together. All right, let's see if that equals will work again for the, no, it still doesn't like that. Okay, let's try that again. Maybe I'll just put the dimension in there itself. So there's something going on where it decided that it's not going to be that right dimension. Let me delete that 0.8 and then try it again. Okay, now I can put that 0.8 back in. Didn't like that either. Okay, let's delete the horizontals. Try that again. Sometimes the computer gets a little goofy, so we got to play games from time to time. Let's try this. So if I do endpoint to endpoint, no, it does not like that. Oh, look at here. It put in a tangent. That's what's going on. That's why we don't want tangents sometimes. They keep us from doing what we want to do. Should have caught that earlier, but no big deal. All right. All the slot is held together well. I do have another dimension here, which is 1.195 inches, and that's from the bottom, or the center point of the bottom arc to the largest line. So let's put that in. 1.195. Okay. A little too big to start with here. Now, if I look, I need something to tie all this together. The center point of that arc should be perfectly between the middle here. So I'm going to use some construction lines since I don't see any dimensions here. And it's not good practice to just put in dimensions that aren't given. So find another way to solve that problem. Here's how I would do it. A midpoint construction line and a coincident relationship. Oh, that got goofy, huh? Bring that back. Okay, let's try that. Let's put in one of those dimensions I took out. Let's put that horizontal back in. Now let's try that center point again. That worked better. So when things get real goofy, you can try and manipulate it. I just like to bring it back and try another way. That seems, for me at least, to be the most effective solution. All right, let me double check these, but overall looks pretty good. Just want to make sure I have the correct dimensions in there. All right, now if I go and I check, that's fully constrained, so I can go ahead and extrude that. And if I refer to my drawing, this drawing down here, kind of that front view, 0.197 is my thickness. Okay, that looks good. Now I'm going to go ahead and cut the holes. Let's do the holes. So I'm going to create a sketch. I'm actually going to go from the bottom. I generally like to, if you see the countersinks go from the bottom to the top, so that's where I'm going to start. So sketch here, 4 holes. I'm going to need 4 points. 1, 2, 3, 4. Not worried about where they are right now. Okay, if I look over here, here's all the information for my hole spacing. From the edge, it's 0.375. In between each hole, spacing-wise, is 0.75. And from the edge is 0.25. And these are all in a straight line, or they all share that 0.25 spacing. So I think it's easier just to use some constraints. Double check my sketch. It's constrained. Fantastic. Open up my hole tool. Select the points that I just created. And now here is where I can put in all the callouts for my countersinks. I have 2 choices here. The drawing gives a distance, but that distance is much further than my part is thick. So it's essentially acting like a through wall. I'm just going to put the distance since I was given it, 1.25, but essentially saying through wall. This diameter is of the countersink, right? So in my hole types, there's a simple hole, and I'm doing a countersink hole. The point of this is I can use a flathead screw and I can completely recess it in the material. That's the advantage of this, of a countersink. There's no hole thread, so I don't worry about tap size. And for drill points, since it's a through hole, it really doesn't matter. It is not going to make a difference to me. But if it was a blind hole that wasn't going all the way through, then this could potentially make a difference. All right. The standard angle for a countersink is 82, so only if you're working with something other than that do you generally need to change it. And this diameter indicates the through hole diameter, which is, if I refer over here, 4 times 0.175 diameter. So 4 of those bad boys. The depth, like I said, already goes all the way through, and here's the diameter for the countersink. So that's 0.175. It was actually already in here because that's probably the last hole I did. But that is my countersink. All right, looks good to me. Use that preview function. It really gives a good glimpse of what it's going to look like when it's all done. All right, so this is the first video of object number 2 here. The second one will go into how to create that linear pattern of all those teeth that neurally now bites into our wood material.